Alright, PreCalc, in this video I'm just going to be walking through the exercises from your notes. We are using the binomial theorem in 9.5 day 2. So 9.5 day 1 was just computing binomial coefficients. Now we're actually using the theorem, and that will incorporate using binomial coefficients. So keep your binomial theorem handy. I'm going to be walking through it, but I don't have the binomial theorem written around here. Keep your formula sheet out. If we want to expand, x plus 1 to the fourth, the binomial theorem tells us how to do that without actually foiling. So what the binomial theorem says is that x plus 1 to the fourth is equal to 4 choose 0, x to the fourth, y to the 0. Or sorry, not y in this case, that was my mistake. In our binomial theorem, x and y are like placeholders. We can put anything there. So in this case, our y is actually 1. So it's like x to the fourth, 1 to the 0th power, plus 4 choose 1, x to the third, 1 to the first power, plus 4 choose 2, x to the second power, 1 to the second power, plus 4 choose 3, x to the first power, 1 to the third power, plus, last term, 4 choose 4, x to the 0, 1 to the fourth power. So this is where the binomial coefficients come in, is that they're what's attached to the x terms, and in this case the 1s. So if you computed 4 choose 0, you would find that that's just 1. So you just get x to the fourth for the first term. 4 choose 1 is just 4 if you compute that, so you'd get 4x cubed. 4 choose 2 is equal to 6 if you compute that. So you would get 6x squared plus 4 choose 3 is 4. So 4x, and 4 choose 4 is 1. So you'd end up with x to the 0th power here, and that's just 1. So 1 to the fourth, 1. So that would be x plus 1 to the fourth totally expanded. Now, for doing these problems, I would recommend having your Pascal's triangle on hand, because it's really nice to not actually have to compute these binomial coefficients. It's really nice to just look at Pascal's triangle and find them. So like on this one, if we would have looked in the fourth row, I'll have to scroll up to my Pascal's triangle. If we would have looked in the fourth row, we would see the 1, 4, the 6, the 4, and the 1. Well, looking back at our expansion, there's the 1, the 4, the 6, the 4, and the 1. So they match up really nicely. That's why it's nice to have Pascal's triangle. Okay, let's move on to the second problem. So again, in our binomial theorem, x and y are just placeholders. So if we want to expand 3a minus 4b, 3a is like our x, and negative 4b is like our y. So in fact, it might even be easier to write this as 3a plus negative 4b to the fifth. So we can see that this is the x and this is the y. So using our binomial theorem, we will get 5 choose 0, 3a to the fifth power, negative 4b to the 0th power for our first term. Our next term is 5 choose 1, 3a to the fourth power, we're just going down by 1, negative 4b to the first power. Our next term, 5 choose 2, 3a to the third power, negative 4b to the second power. Next term, 5 choose 3, 3a to the second, negative 4b to the third. Just notice that your powers always add up to 5. So 5 and 0, 4 and 1, 3 and 2, 2 and 3. And as we move along, the x term is getting smaller powers and the y term is increasing. So now we have 5 choose 4, 3a to the first power, negative 4b to the fourth. Last term, 5 choose 5, 3a to the 0th power, negative 4b to the fifth. Okay, so that's the whole thing written out. Now comes the mess that is actually computing what all this stuff is. I gotta grab a calculator. Okay, so 5 choose 0 is just 1, so that's nice. We just have a 1 for that first term. But now we have 3a to the fifth, and we not only take the a to the fifth, but we also have to take the 3 to the fifth as well. So there we're going to end up with 243 a to the fifth, and negative 4b to the 0th power, well, anything to the 0th power is just 1, so that term just goes away. Okay, 5 choose 1 for the next term, that's a 5. And then we're doing 3a to the 4th power, so we need to do 3 to the 4th power, that's 81. And a to the 4th power. And now we have to do negative 4b to the first, so that's just negative 4b. Next term is 5 choose 2. Really nice to have your Pascal's triangle on hand. I'm just looking at mine in the room. So we have 10. Hey, how's it going, guys? You put it on the desk. So we have 10, where are we at? 3a to the third, so that's 27a cubed. Negative 4b squared, so that's 16b squared. That's our next term. Okay, moving on to 5 choose 3. 5 choose 3 is also 10. So we'll have 10, 3a squared, so that'll be 9a squared, and then negative 4b cubed, so that will end up being negative, that's going to be tough to fit in here, negative 64b cubed. Alright, move down a little bit. We got 5 choose 4, that is equal to 5. 3a to the first is just 3a. Negative 4b to the fourth, so 4 to the 4th power, there's 256. So 256b to the 4th. Plus 5 choose 5, which is just 1. 3a to the 0, which is also just 1. Negative 4b to the 5th is negative 1024b to the 5th. Okay, we computed all our coefficients and everything. Now we just need to simplify a little bit, try and simplify this mess. When we're done, it's not going to be all that simple. I mean, the numbers are still going to be big, but it'll be a little bit better. We'll get 243a to the 5th in the first term, minus, because we got the negative on the 4, negative 20 times 81, 1620, a to the 4th b. So plus, for the next term, just multiplying all these numbers together, 27 times 10 times 16, 4320 a cubed b squared. Minus, for the next term, we got that negative 64. $5760 a squared b cubed plus, getting close, 5 times 3 times 256, 3840, a, b to the fourth. Now, last term, negative 1024, b to the fifth. This whole polynomial right here, that is the full binomial expansion of this little thing right here. So this thing up here is the factored form of that. Yeah, so that's how you use the binomial theorem to expand that one. I think on these next ones, I'm probably not going to do all the calculations. I'm just going to kind of set them up. So again, we're expanding x squared plus y squared to the fourth. So in this case, it's kind of like x squared is our x. I know that maybe sounds a little bit confusing, but y squared is our y. So if you're looking at your binomial theorem, those are your placeholders. So if we expand this, we're going to get 4, choose 0, x squared to the fourth, y squared to the 0, plus 4, choose 1, x squared to the third, y squared to the first, plus 4, choose 2, let's see, x squared to the second, y squared to the second, plus 4, choose 3, x squared to the first, y squared to the third, and then plus 4, choose 4, x squared to the 0, y squared to the fourth. So you can go ahead and do the work of simplifying this. Again, it's just a little bit of tedium, but that would be how you use the binomial theorem to expand that one. Okay, last one. This problem isn't asking us to expand the whole binomial. It just wants us to find the third term. Now, that can be a little bit tricky because if we remember, like back in Pascal's triangle, we start at the 0th row. So if we look down here, maybe this one would be easier. We start at the 0th row up here, x plus y to the 0. And also, we start at the 0th term. So if we're looking at like, you know, all these ones here, those are the 0th term of our row. So in terms of the problem, what that means is we're trying to find the third term, but we're not going to do 5, choose 3. We're actually going to do 5, choose 2 because we're at the third term, but that actually ends up being 5, choose 2 because we start with 5, choose 0. So we'll have 5, choose 2, x to the third, because it's 5 minus 2 up here, so to the third, and then negative 6y, because that's like our y in our binomial term, there's x and y, negative 6y to the
Please
second
excuse
power.
this interruption for one quick announcement. Attention GFC speech team. You will not be attending the Fargo-Davies speech tournament tomorrow, March 24th, due to weather. You must stop into room 158 today so your coaches know that you are aware of this change. Again, GFC speech team will not be attending the Fargo-Davies speech tournament tomorrow due to weather. You must stop into room 158 so your coaches know that you are aware of this change. Thank you.
Okay, so this is the third term of our binomial expansion. So if you wrote it all out, this would be the thing that comes third. Yeah, so these are just the examples of working through the binomial theorem. We will see you in class.